Here we're going to finish up our geometry section by looking at a very brief introduction to circle equations and circle theorems. Now, circle equations can be presented in a couple different ways. The standard form is the easiest and hopefully the most common method that you'll see, where the center and radius are actually given from the standard form. X minus h squared plus y minus k squared equals r squared, where the center is going to be the values of h and k. Notice there will be a sign switch based on the equation that's given, and then the constant term will be the square of the radius. So if we square root the constant term, we get the value of the radius. We square root the constant term, we get the value of the radius, and that tells us where a circle is going to be located within the coordinate grid. The other way that you might see the equation of a circle, less common on the SAT, but we'll cover it later in our course, is in general form. And general form is a little bit trickier to kind of read. And it is generally something like ax squared plus bx plus cy squared plus dy equals c, or e, some other variable. And so we have two terms with x, one squared, one linear, two terms with y, one squared, one linear, and then we have a constant term. And in general form, in order to get it into standard form, we have to factor by using the completing the square method. Completing the square. So we won't have time now to go into the concept of completing the square, but I encourage you to try and find some resources that go through how to complete the square on the general form of a circle in order to get it into standard form. Because depending on how you do on the SAT, you may be given a question in general form, and you'll have to convert it into standard form. The alternative is that you can also type it into Desmos on the graphing calculator in order to identify where the circle and the radius are. That'll be faster than doing completing the square. So let's take a look at some examples and see if we can figure out where these circles are located. So if all points on a circle are in quadrant 1 in the xy plane, which of the following could be the equation of the circle? Well, the first thing we want to do is we want to figure out where the center is, and we want to make sure the center is in quadrant 1. If we look at this diagram up here, this circle passes through all 4 quadrants. We want a circle that is only in quadrant 1. And so let's first look at where the center is located. Well, here, if we look at our formula, we have x minus h and y minus k. There's going to be a sign switch for our center. So this circle has a center located at 6, 5. Well, 6, 5 is in quadrant 1, so that works out. So this could be the circle. If we look at this next one, this one has a center located at -6, -5, which is in quadrant 3. So it's not going to be this circle or this one here, which has the same center. So now we're looking at only these two circles here, which have centers in the correct place. And so we have a center located at 6, 5. And here we can actually look at that on this diagram up here with a center located at, oh, that's 5, 6. Let's make it 6, 5. There we go. Located at 6, 5. So we're in quadrant 1. Now we need to look at the radius. Well, the constant term is the square of the radius. So if we square root 16, we get a radius of 4, versus when we square root 64, we get a radius of 8. Well, looking at our center, if we have a radius of 4, 1, 2, 3, 4, this is as far out as this circle extends, and it continues all the way around. But if we had a radius of 8, it would go well beyond into the other 2 quadrants, and that means this circle is going to be too large. So it can't be circle C, it has to be circle A. Here we want to find the diameter of a circle given the equation. Well, recall that diameter is equal to 2 times the radius. So first we need to figure out what the radius is. Again, we look at our constant term. The constant is our radius, or the square of our radius. So since radius squared equals 6, radius equals the square root of 6. And then in order to get our diameter equals 2 times the square root of 6, so diameter is just 2 root 6. We could estimate this by plugging into our calculator, and we could also get a rounded value. Next, we have a circle in the xy plane with a center of -3, -4, and a radius of 5. Which of the following is the equation of the circle? Well, if we remember our standard form, x minus h squared plus y minus k squared equals r squared, we can substitute in the values for h, k, and r. X minus -3 squared plus y minus -4 squared equals 5 squared. Well, 5 squared is easy. That's going to give us 25, so we know we can eliminate those two options. And then because of the negative, we're going to have a sign switch, leaving us with x plus 3 and y plus 4. So our circle is circle D.